gave us this. So the 0.6 is going here. What is going here?
0.25,
What's going here?
0.45,
Do we know this? No. So they're changing the order around. We gotta do a little algebra, y'all. Holy cow. What do I do? Add these up. Okay, and then subtract it. So we're gonna add up the 0.25 and the 0.45. That gives me the 0.7. Let me highlight so you can see where it came from. I added those up. It gave me that. Then, just to show you what I'm doing, I'm going to subtract 0.7 and subtract 0.7 from both sides. That gives me a negative x equals a negative 0.1. What do I need to do to both sides now? Divide by a negative 1, because you can't have that negative x. So you're going to divide both sides by negative 1. And that's going to give you your final answer of x equals 0.1. And you were solving for P, the probability of E and F. You were not getting the front side. All right, let me give y'all one to do. Let me grab these again, because I think those are for all of these problems. Paste. All right. How that one? You're finding P, the probability of E or F. It should be easy if you know what mutually exclusive means. All right. Mutually exclusive means what?
they do not occur.
They don't have anything to do with each other. They're independent. So this means double dip, which means overlap. So if they're mutually exclusive, what does that tell me about the overlap? There is none. So what is the overlap going to be?
0.
0. So what is this?
0.25,
0.25. What is this?
0.45,
What is this?
0.
So mutually exclusive tells me there's no overlap, which means the double dip is going to be 0. So it's going to be a 0.25 plus a 0.45 plus 0. And that reason that that is 0 is because there's no overlap, because they're independent. They're mutually exclusive. All right, number 16. I want you to find the probability of E and F if E and F are mutually exclusive. So I want to know the probability that something's going to be on Ella and Frank's list if Ella and Frank are mutually exclusive. Find the probability of Ella and Frank if Ella and Frank are mutually exclusive. So what's the probability of me finding something that Ella and Frank like if Ella and Frank are mutually exclusive?
0.
0. I can't make Ella and Frank like something if they're both independent and they have nothing in common. So mutually exclusive is telling me that there's no overlap. And means I'm looking for the overlap. So I can't find an overlap if I'm saying that they don't have an overlap. All right. Let me grab these two again. Copy. And paste. Find the complement of F. If F is 0.45, what is this complement? F is 0.45, what is its complement?
You want to answer aloud?
Give it to me, Josh. 0.55. If you make free throws 45% of the time, how much do you miss the free throws? 55% of the time. That is going to be its complement. The free throws are going to be the rest of the story. Everything else. If PE, the probability of event E is 0.6, and the probability of E or F is 0.85, and the probability of E and F is 0.05, find the probability of F. Do you remember the formula? The probability of this is equal to the probability of this plus this minus this. The probability of E or F is equal to E plus F minus the overlap. The probability of the OR is going to be the probability of them individually added up minus the overlap. Let's see if I have it written down right here. Here's the formula. The probability of the OR is equal to the probability of them individually added up minus the overlap. So you've got to fill in what you know and solve it. You done? Let me see.
I realized I messed up.
Yes. Good job. Done? Oh, I could probably need more than one. Yep. All right, what am I putting under this? 0.85, right here. What am I putting under here? 0.60. What am I putting under here? X. What am I putting under here? 0.05. Okay, so we're just plugging and chugging. They told me this was 0.85. They told me PE was 0.60. They told me to find that, and they told me that was 0.05. Now, I have 3 pieces here. I'm going to put these 2 pieces together. So it's 0.6 minus 0.05. So when I put those 2 pieces together in my calculator, that minus that, that's going to give me 55 cents. And then I'm going to subtract 0.55 from both sides. And I'm going to get my 30 cents, or 0.3. And then I've got to remember, what was I solving for? I was solving for the probability of F. All right, let's try one more of those. Let me give you the formula. The probability of the OR is the probability of each one added together minus the double dip. There's the formula. Done? Is that what I do?
No, I had realized it was still there. I had changed it to 3.
I think those are good.
Good.
Yes, sir. Yeah. You're good, you're good, you're good. Good. Yep. Yep. All right. They told me that the E or F is going to be 0.65, which is going to go here. The probability of E we don't know. The probability of F is 0.30. And the probability of the overlap is 0.15. So once I plug in, I'm going to combine my 2 at the back. That's going to give me my 0.15, and then I'm going to subtract the 0.15 from both sides. And that's going to give me my final answer, which is 0.5. And then I've got to remember, what was I solving for? I was solving for the probability of E, is 0.5. And again, those are not on the test, probably just on the homework. All right, gambling and guns. We're going to a gun problem. We have a probability distribution, which means all of our probabilities are between 0 and 1. If we added all of those up, it would add up to 1. These are how some murders took place. It says verify that it is a probability distribution, and the way that we verify is that our numbers are between 0 and 1, and that they add up to 1. What is the probability that a randomly selected murder resulted from a rifle or a shotgun? A rifle or a shotgun. How would I do that?
Add up those two and.
What, is there any overlap?
Mm-mm.
No, it's either a rifle or a shotgun, there's no overlap. So it would just be the rifle plus the shotgun. So, there's my rifle, there's my shotgun, there's no overlap. So it's gonna be .023 plus .025. And what does that give me? 0.048. What is the probability that a randomly selected murder resulted from a handgun, rifle, or shotgun, a firearm? All right, for that one, he's saying a handgun, a rifle, or a shotgun. What would I do for that one? Is there any overlap? Overlap? No. So for that one, there's no overlap. So we don't have to subtract the double dip. So it's going to be .472 plus .023 plus .025, and that's going to give me .52.
For that one, shouldn't unknown firearm be included? Because it says in the parentheses, the purpose of it is to determine what's the probability that a firearm is
Yeah.
used. So
Yeah,
unknown
and
firearm
these
should
down
be
here, a firearm, that shotgun. A shotgun firearm. And what were you saying?
Well, I was saying the parentheses imply that the purpose of this is to include all firearms.
So you're thinking we need to include the
So-
.170?
Yeah, unknown firearms should be included in that as well.
They didn't.
That's not how the problem is worded, but
Right.
it seems like.
I
it should be.
totally, if it was a test question, I would totally, because I can totally see that you would include the .17. They didn't, but I can see how it would go either way. Yeah. Because it would make you think that they're including all the firearms. I totally could see that. What is the probability that a randomly selected murder resulted from a weapon other than a firearm? Now for this one, which kind of says what you say, they did not use the unknown firearm for part C, but for part D, they did. They said, what is the probability that it was from other than a firearm? So what numbers are we going to use? So they want to say, I don't want to be shot by a firearm. So which ones are we going to use? The knives, the hands, fist, and other. Now, you could do one of two things. You can add all the guns up and subtract it from one, or you can add up the non-guns. It's totally up to you. I'm going to add up all the things that are not guns, but you could have added up all the guns and done the complement, the one minus the guns. You could have done that as well. So I'm going to do .122 plus .056 plus .132 and gotten .31. Are murders with a shotgun unusual? What makes it unusual? Less than .05. So the shotgun is .025. Is it unusual?
Yes.
Yes, because .025 is less than .05. And I did write down here all the prettier And for the gun, I actually did the complement. I did 1 minus all the guns instead of doing the not guns. Where up there, I did the knives, the other, and the whatever the other one was. Here, I did 1 minus the guns, just to show you it'll give you the same answer. But there's the prettier writing. All right. This shows us a random sampling of housing units and how many bedrooms they have. What is the probability that a randomly selected housing unit has 4 or more bedrooms? 4 or more bedrooms. Now, notice on the last problem, and this is the same thing that got y'all on the test. Here, we're talking about probability, so we straight up use that number. That was our probability. What are we doing here? Is that the probability? No, that is the frequency. So what do we need to do to this number? Divide it by the total. So this is not the probability. You need to find the total, add them up to find the total, and then divide. This is frequency, not probability. So, what does that add up to be, somebody? 1,000, I think. It adds up to be 1,000. So if we want to know probability, it would be 5 over 1,000, 11 over 1,000, 123 over 1,000. So for the first question, it says, what is the probability that a randomly selected housing unit has 4 or more rooms? 4 or more. So I'm going to do 183 plus 230 plus 204 plus 123 plus 156 all over 1,000. And I have the answer written prettier. What is this, 30? Right here. And what I did is wrote them individually. The 183 over 1,000 is 0.183. 230 over 1,000 is 0.230. 204 over 1,000 is 0.204. So I just wrote them individually and added them up. Cool? All right. What is the probability that a randomly selected housing unit has fewer than 8 rooms? Fewer than 8 rooms. What would I do there? Easiest way to do it is a complement. Instead of adding up all of these, I would do 1 minus 156 over 1,000. Because if you know these are 8 or more, everything else is going to be fewer than. So to get the complement, if you knew that 8 or more is 156 over 1,000, or 0.156, fewer is going to be everything else, or the complement. So I did 1 minus that probability. Make sense? That's the everything else. All right, D. What is the probability that a randomly selected housing unit has at least? Now, y'all, here is, anytime I hear at least, I do 1 minus. Anytime I hear at least, I do 1 minus. So I'm going to do 1 minus the 2 rooms. Or 1 minus the 1 room. So at least 2 rooms. So I want at least 2 rooms. And when I hear at least, I automatically think it, 1 minus. So I'm gonna come down here and show you. At least 2 rooms. I always do 1 minus. It never fails when you hear at least. Always do that 1 minus. It'll always work. You want at least 2 rooms, so at least 2 rooms. The only thing that you don't want is 1 room. So if you get rid of the 1 rooms, everything else is going to be the at least 2 rooms. So if you can get rid of the 1 rooms, at least is going to be the everything else. So at least is going to be your 1 minus, and what do you want to get rid of? You want to get rid of the 1 rooms, and everything else is going to be your 2 rooms. Now, what number is this? This is number 30. 5.2 starts here and ends here. Do we see any number 30s? All right. Let's look at, we should be getting into a deck of cards. How many of us, raise your hand if you're familiar with a deck of cards. Okay. Some of us are not familiar with a deck of cards, so I want to talk about a deck of cards for a minute. I have a deck of cards pulled up. It's not a very pretty deck of cards, but a deck of cards is 52 cards, okay? 52 cards. It has 4 suits. There's diamonds, clubs, hearts, and spades. Diamonds and hearts are red. Clubs and spades are black. So half of the cards are red, half of the cards are black. There are 13 cards in each suit, okay? And when you go take a test, they will give you one of these to look at. So you don't have to memorize all this. They'll give you one to look at. And what I'll do is I'll put this in your notes as well. And you can easily Google deck of cards when you're doing your homework. Let me put this, because I realize some people are familiar and some people aren't. So there's 52 cards. There's 13 in each suit. This is a club. No, that's the spade. This is a spade, a heart, a club, and a diamond. Now, these at this end, these are called face cards because they have cute little faces on them. Okay? The book, and I've never heard it called this before, the book calls these courts. These are called face cards or court cards. Because it was a jack, queen, king, those were the court, the gesture, the court, queen, those were just the court, or I usually call them the face cards. So this is kind of what you need to know. Probability deals a lot with gambling. We usually use dice or we use cards. So if you are at home and don't want to bring this up, you can easily go to Google, just to show you. And just type in deck of cards and then go to images. And just get one that has a full deck and it'll give you all of the ones that you can pick from. And I just pulled one for you to see. So that's kind of what you need to know. So, it tells you that a standard deck of cards contains 52. One card is randomly selected from the deck. Compute the probability of randomly selecting a 2 or 3 from a deck of cards. So, if I pull back this up, we're picking a 2 or a 3. So I've got to do the probability of a 2, the probability of a 3, minus any double dipping. So what's the probability of picking a 2? 4 out of 52. What's the probability of picking a 3? 4 out of 52.